All right. Make sure you take notes all the way through. If you're thinking, hey, if it's not on the homework, I don't have to take notes, you have a T that you're going to need your notes for. And so if you don't have it, you can recreate them from YouTube videos, or you might have a very friendly, nice cadet in class who might share with you. But the best is just to take notes yourself. I can tell you right now that you don't know what's going to happen. Shut down the computers, close your computers. You don't know what's going to happen. Like, you might decide you're 2-3 years out in the field and you're going to come back and go to grad school. I see it all over the place. Cadets that you never think would come back they want to come back and teach, or they want to get a master's degree in something. So keep your notes. Don't do as I did. I had nothing. I came empty-handed to Georgia Tech. And I wish I had kept my notes. Okay, so.
Just curious, did you just do a master's degree, or?
No, I did not.
Did you just do a doctorate degree?
Only a doctorate.
Okay.
So back then they were trying to get young people to get their. I didn't know this, but we had this NSF funded thing in the summers, and it was to get folks to go straight to grad school because they saw that the Vietnam era was going to math professors were all going to retire at once. The only problem was when I finished, they didn't retire. They kept hanging on for another 20 years. And but like when I got hired, the last person who was hired in my department was 10 years older than me, like hired 10 years before me. There was nobody hired in between. So there was like this clear divide between.
Did you feel like at a disadvantage because you didn't do a master's program?
No, I think they made a call, like if you want to go get a master's, like on your way to PhD, you can sign something. I was incredibly lazy, so I just like, I'm not going to sign that. One less thing for me to do. All right. So a master's degree is great for if you're going to work. I think once you get a PhD, there's like all kinds of suspicions. You might just like to do research and they don't want you in an industry. Like one interview I had, they really asked me, are you going to be really worried about getting things exactly perfect? Because I try to get things perfect. You're working with me a little bit and you're working with me. Like I like to get those things perfect for papers because people can review the papers and then come after you if you have mistakes in it. So, but in industry, you just need to explain to someone, like we know the answer long before we have proofs and everything. So, how you feeling? Better? I just posted the video, so I was going to talk to you after, Steve, like if you need extra time. Okay, it was good. So yeah, master's degrees are great for like people who finish with their master's degrees at Georgia Tech got jobs at Equifax, the credit card company that does credit scoring. They got jobs at Scientific Atlanta. So the jobs are plentiful if you have your master's. I think PhD, then you start to have a little too much education. Some jobs require a PhD. I've been in academia too long, so they're really worried about me. All right.
Go back and like work on the outside, what would you do?
The first time I tried was before I came to West Point, and I learned a lot from just applying, sent out applications, and then I could see, as a recruiter, you can actually see if people are looking at your application, and I started tailoring my resume more to skills. I think this time I have the skills of leading the NIH study for the consortium, and I just have to learn how to market that. So to say like I have managerial skills. You guys also will have that issue because the stuff that you do in the Army, it's not going to be easily placeable on your resume, but you will have more leadership experience than a lot of the people that are working right within industry. It's just that if someone comes out with an MBA straight out of school, that's a known quantity. But if you try to like dress up what you actually did as a lieutenant, it's not going to look the same. And so you want to get that resume looked at. My brother just gave a talk on this. I can send you the slides. I thought they were really interesting. Just how he said to redo your LinkedIn page and how to make that connection so people actually look at your resume. We don't have a career office here, so we build ours in. All right, so let's talk about Cauchy criteria and other direction. If it's Cauchy, then XN converges. So this is the harder direction. Lazy Dr. T went through the easy direction first. I like to get the easy things cleared out, then I feel like I've accomplished something. And I gave you the sketch of the proof the other day. The first is that you want to show that this Cauchy sequence is bounded. This is what you know by the definition. I just rewrote my note. If I'm ever not looking at something and I'm writing on the board, it means that I've had to do it more than once. Like I really remember it. So I know this definition like the back of my hand. I was talking to a cadet candidate and he was worried about taking that test in Beast. And I said, if you really know it, it doesn't matter where you take it. Okay. So you guys were weirded out with setting epsilon equal to something. That statement is true for every epsilon. So in particular, it's true for epsilon equals 1. I can find an n. I'm going to set my m equal to n1. So what I'm doing, like that's what you're doing when you're doing the numerical analysis tall thing. You're actually just taking differences between the next two. That's because you know it's, if you can show it's Cauchy between the next two, that's kind of almost good enough. There's actually, I think a theorem in your book that says something along those lines. So I'm allowed to set the n and the m to be something because it's true for all n and m bigger than this n1. So I'm going to set my m to be n1, and then I have xn minus xn1 must be less than 1. And so by the reverse triangle inequality, so I have that. So what this is telling me is, if I go far out enough in the sequence, all those members of the sequence are going to be bounded. It's really the tail end I care about. I don't want things to go haywire there. The first part of the sequence, up to x sub n1, the first part of the sequence, it might do crazy wild things, but it's a finite sequence if I just cut it off at xn1. So
Cauchy,
right on the board.
at any point, it decides that it's
This
gonna.
is the definition of Cauchy right here.
So does that mean there's like some point, like the first starting sequence, it could do anything, including have like a difference that's greater than 4.
Yes.
And then at some point, it's like, okay, gotta lock in.
Yes, that's right. Gotta lock in. So
Sorry.
I love using the horizons and comments. I completely meant to say buttons.
So it could do something crazy right at the beginning of the sequence. You could have a million really large numbers, but it doesn't matter. There's got to be, even if it does something crazy, I can just take the bigger of these two. I can just take, if there's a huge number over here, I'll let that one be my bound. If those are all small, this one's the bigger one, I'll let that be my bound. So xn is bounded.
So is the 1 plus at the end, is that just because our epsilon is 1?
Yes, because I set epsilon v1. I did this magic over here. I erased the magic, where I just set up, I'm allowed, because of the definition of Cauchy, that's where I use my hypothesis. It allows me to set, says for every epsilon. And specifically, epsilon equals 1, it works for. And so I know that in the tail end of the sequence, I can squish it down below this guy. So when n's big enough, it's squished down below this guy. Before that, it's just a finite set of numbers. So there's got to be a biggest one. I think you guys had a theorem like that. I mean, she probably talked, Dr. Moen probably talked about that. That if you have a finite set of numbers, there's got to be a maximum. So take the bigger of those two, the maximum of the first part of the sequence, and this 1 plus absolute value of x n sub 1, and it's got to be bounded by the bigger of those two, the whole thing. So the sequence is bounded. What do I know if the sequence is bounded?
Yeah, convergence.
Not sequence. Sequence by now. Minus 1, 1, minus 1, 1, that's bounded but doesn't converge.
So,
Bolzano-Weierstrass says
so
as a subsequence that converges. It's like weird that you see Bolzano-Weierstrass, you understand the proof, and you're like, where the heck would that be used? Here's where it's going to be used. So my issue with this theorem, proving it straightforward, is I have to show that xn converges, but I don't have a candidate for what it converges to. So I have no idea where it's going. I can't just say x can be anything. X has to be something very specific if it's converging to it. So this gives me a candidate. That gives me the candidate for what it converges to. If you just try to go straight and try to prove this, you're just going to run into this trouble that you don't know what it converges to. So how are you supposed to show? Because in the theorem, in the definition of convergent sequences, you have to show xn minus x is less than epsilon at the endpoint. And if you don't know what x is, how are you supposed to show xn minus x is less than epsilon? Now I have a candidate what that x could be. Let me put hat bars over this. So it's like, these ends may not be the same. So that's why I had to, but I know that if I choose them to be the max, let you catch up. You know what I'm going to do. As soon as you see the epsilon over 2 appear, you know what I'm going to do. Triangle inequality, adding and subtracting.
Is the like the squiggly end different from the cap end?
Yes, because they might not be the same, right? One's a subsequence, so I might have to go out farther or do something different than the first one. But if I let n be the max of both of those, then both of those statements are true far out enough after that capital N. What I have to show, I should actually be putting down what I have to show. I'll slot myself later. Wait, push-ups, right? That's what we're supposed to do. They can't make you do that anymore, right? Push-ups for making mistakes.
It depends where.
They fully.
They just don't anymore. In Beast, yeah, for sure. I want like leave your there was one Thursday who like made me and somebody else do push-ups. They might be bringing back.
No, our company's been sending people.
Really?
So there's a group of like 4 firsties that hang out outside the barber shop for lunch. And they just like correct people as they want time. So I feel like if their power is left unchecked, that they're gonna start doing
Push-ups?
Yeah.
Okay, I will self-impose push-ups on myself for not writing show what I have to show. But I really have to show that this thing is less than epsilon if I'm going to show x and converges to x. So that's less than or equal to this. This is equal to this. I still remember Cadet Perry looking at me like, what do you want me to do? Add a 0. Adding a 0. I haven't really changed anything. And that's xn minus xnk plus xn k minus x. Right here to here is triangle inequality.
So before that was x, and then at the end it's x1.
Oh, sorry, x. And then this is less than epsilon over 2 because n and nk are both, it's a Cauchy sequence. So this part is the Cauchy sequence part. Because it's far out enough, I know that these two tail end pieces the difference must be less than epsilon over 2 because I set it up that way. And this converges. So I get epsilon. Voila. All Cauchy sequences converge. On R, because if this is Q, that wouldn't be true. The limit's not going to be real always. So on the real numbers, this is true.
Can you say that doesn't mean like the limit's gonna be complex, or just that it's not gonna be in Q?
It could be, might not be in Q. That's usually how you get non-completeness. All right, is it clear? I went through that pretty fast. Step 1, show it's bounded. Step 2, do that trick with the triangle. If it's bounded, then Bolzano-Weierstrass says that it has convergent subsequence. That's your candidate for the limit. Claim xn converges to x, which is the limit of that subsequence, and do that triangle inequality trick to make it happen.
Just to confirm that. Bolzano-Weierstrass requires that it's bounded.
Yes. If it's bounded, then it has convergent subsequence. It's a really, really powerful theorem. We actually spent, I was laughing with Dr. Loss, Michael Loss, he was my PDE teacher, and we spent an entire quarter proving one thing. And it was always, it was a convergence theorem. He wanted to show something converges, and in this case, it was sequences of functions. But he didn't have a candidate, he had nothing. So every day he'd start out and say, let's pass to a subsequence that has this property. So the subsequence doing something can get you that result at the end. And that was for PDEs, which is a very applied area. And he gave me an extra copy of his book because I have my book is signed by him and Lieb, who both wrote it. Lieb, I think, was a Fields medalist. And I don't want to loan that book out. So he gave me a book that I can loan out. I said, I don't want to loan a book that's signed because if I don't get it back, I've got it signed by both of you.
PDEs is what convinced my grandpa to go from math to physics as his major.
So I think Elliot Lieb is a math physicist. Okay, so that's it. That's the proof.